what we're going to do here is we have to create models that represent the table. Like we just created a table in the migration file. It's possible to work without a model, but it can only do the most basic things. So we're going to create a model for winery because we want a winery to be linked to a location. And so we need to set up the manifest. With DTCMS, you can do all of this through a GUI, but we aren't going to use DTCMS for this. Basically, we're going to modify our code to do this. So I'm just going to copy and paste this into the model file that we looked at earlier. So, oops, not that one. We're going to go to our winery source model. This sample file, I'm just going to duplicate this. I'm going to call it winery. And I'm going to paste my code in here. You'll see basically we added a has a manifest, which is a deep dot function for connecting models, basically declaring the relationship a winery has a location. Mm-hmm. And then we expose a few of our attributes. And the exposing the attributes is basically what allows those properties to be viewed if someone makes a request to the API. So if we get that far, I'll show you when we pull this data from the backend, we should see this structure in the request responses. So for now, the reason that we created this model is because now we want to create a blueprint that can pull in the data from the CSV file. And to use that blueprint, we need our models. So this is the blueprint that describes the winery data. And to sort of talk about the structure of it, we start with basically for CSV files, this is a row-based description of the structure. So we say every row is a model, it's a winery, right? That makes sense. We have a list of wineries, right? Mm-hmm. Now, most simple things are a mapping from a column name to an attribute of the model. So we saw these were the three properties that I have in my model that I exposed. These share a name in common with the database structure, so that makes them like a straight through shot. We basically, owner goes into the owner column of the database. If we need to do some mapping, we can, but we don't. So basically, this allows us to take whatever the raw format is and turn it into our own structure, which is important because you don't want to have to do a lot of mapping during the ingest process. Like you don't want to have to rename things manually or anything like that. You want to just be able to accept it in the format it's given to you so that the next time we go back and run it again, we don't have to make any changes. We can make this pipeline that we just go get the data, bring it in, go get the data, bring it in. So this mapping process is very important. This is a little more complicated. What it does is basically remember that a winery has a location and it links to it by the location ID. So when we set up the blueprint, we say, this is the location ID property, but it doesn't map to a column because that location ID is actually going to be an integer foreign key to the location table. So rather than filling it in with a column name, we say, no, inside the location is a model. So we've nested another model inside of here. Now this model actually comes from our location plugin. So you can see by the namespace that it actually goes to API location. Mm-hmm. Now within a location, we can do the same sort of mapping. Basically, there's some columns we want to map to city and county, and then we do the same thing again. The state ID is actually linked to another table. So we have a model, comes from the location plugin, and then we map it, basically the abbreviation of the state matches up to the state column and the street address. And so it looks really easy, but there's a lot of magic going on underneath here. This is literally all it is. I guess I'll show you the thing working, and then we'll talk about how it goes. So we'll go to our scripts folder. I'm going to create a new folder called BP to store our blueprints in. And I'm going to create a file called wineries.yaml. I put my YAML code in here. So when we run DTQL on this file, it's going to use this structure to map every row of the CSV into our database. So let's see that happen first. So here I'm going to run API vendor ben DTQL. That's our command line tool. I'm going to tell it that I want to scrape something, and I have a blueprint, which goes in the scripts folder, BP wineries YAML. I also want to connect it to a form of storage, so I'm going to set up the data source name as an SQLite reference to my storage DT development file. So this is where our development SQLite resides. And then I'm going to actually bring in some rows of data. So we're going to hook this up to data wineries.csv. So those are all the pieces necessary. I'm going to go ahead and run this thing. So it's actually going through every row of the file now, 1,000 transactions at a time, 1,000 records per transaction, and it's putting these in the database. So there's about 8,000 records in this data set. But we can go ahead and look at the locations, for example. This is actually pulled in everything. It's got our state IDs. Now notice it didn't create a new record for every state. It's just mapping to these. We do an upsert so that the location, anytime that the properties, like we're loading up the state ID here, so it's going to look for a state where the abbreviation already matches the value in that column. If there's already a record that matches that, we're going to use that ID instead of creating a new one. So it's upserting. It updates if it needs to, it inserts if it needs to. It will, by default, the upsert matches all the properties specified. So for example, this location, you're going to have, it needs to match on every single one of these values, or it's going to create a new record. If you wanted to match on a subset, for example, wineries, it might make more sense to only match on the TTB number in case we have, like down the road, maybe the winery changes its name, but we want to capture that. We don't want to create a new winery and end up with a duplicate value. So if we do a thing called BP filter, and it's a list of the properties that we use to identify a matching value in the upsert. So if I just set this to TTB number, now my winery, when I upsert the value, it only tests this parameter, this property, to find a match. So it's not, first of all, that's performance improvement. And second, it allows our data to mesh together. Even if we span a bunch of data sets, we can actually just keep the unique identifiers as the filters, and the data will actually just slide into place. In fact, I can run this scrape as many times as I want, and it's not going to create additional records because it already knows how to do its thing. So let me save this file. And we changed the filter here. So it's actually going to be slightly different, but it's matching on a value we already know. These TTB values, TTB numbers. So we have 7,310 records here. When I run this again, I don't expect any new records because of the upsert process. Okay, so that's basically it. Oh yeah, our scrape finished. So let me show you that it did not add any new rows. Right, 7,310, still our total. All the data stayed the same. We have this nice set of well-connected data. So that was it, by the way. We didn't write any code to ingest this. We added a model, which we're also going to use for the API. And that was the whole process. We just built an API using all the national winery data.